Okay, 39 is again inverse matrix, but in this case we are only using calculator because you see it's too long and complicated. Okay, I edit the matrix, the original matrix inside the matrix. Let me check. Okay, this is our original matrix. Now for finding the inverse, you press inverse. Wow, it's decimal. Let me convert to the fraction. So when you convert to the fraction, math, enter twice. It's the answer. Okay, let me copy the matrix. The inverse matrix is 10. Negative 5 over 7, 1 over 7, 3 over 7, 9 over 7, 1 over 7, negative 4 over 7, 3 over 7, and negative 2 over 7, and 1 over 7. Okay, let me check it just in case. Negative 5 over 7, 1 over 7, 3 over 7, 9 over 7, 1 over 7, negative 4 over 7, 3 over 7, negative 2 over 7, and 1 over 7. Let me store this information, this in the matrix B. In the matrix B. Wow. Deal. Matrix B. Now let's do a multiplication. Matrix A times matrix B. And the answer is identity. Now in different order. B times A. Again, it's identity. Perfect. Okay, 41 is example. Okay, you solve the system by using inverse matrix. Okay, let's do it 41. I put the determinant of the system. I solving. This is plus minus. This is 2 minus 1 gets 1. Okay, it's different to 0. The inverse exists. Because the matrix A is 2, 1, 1, 1. Remember, cofactor matrix, when it's 2 by 2, you interchange this 1, 2, and this is negative 1, negative 1. Cofactor transpose. It's the same. It's the same because this matrix is symmetric, so it's the same. Now finally divided by 1, I'm going to find the inverse. This is the inverse. It's exactly the same. The cofactor transpose is exactly the same with the cofactor. Okay, now in order to find the vector of the variable, you apply the formula. The formula is A inverse times B. A inverse is 1, negative 1, negative 1, 2 times the vector B, is the vector formed by the right hand side number. In our case is A and 5. A and 5. Okay, this is 2 by 2, this is 2 by 1, matching perfectly, and the new answer is 2 by 1 is just a vector. So it's this times this. 8 minus 5 is obviously 3. And negative 8, this times this, plus 10 is 2. The answer is a vector 3, 2. It's obvious that x is equal to 3 and y is equal to, so the solution is the order pair 3, 2. Okay. Okay, 43 is similar because it's the same matrix A. The only key change is the vector B. The determinant is the same, the inverse is the same. I don't need to compute again. It's 1, -1, -1 and 2. And the only thing you should do is multiplication, this matrix, by the new vector big, in this case is 0 and 5. Okay? Entonces this times this is obvio que es -5, only because 1 times 0 is 0, -1 times 5 is -5, and this times this is -1, 0 is 10. The answer then, remember this is a vector xy, x is -5, y is 10, the other pair solution is -5, 10. Okay, 45. 45 is similar, but this is the determinant of the system. Multiplication, this and this, this and that. This is 12 minus 10, que es 2. Okay, now let's go. The matrix A is the matrix 6, 5, 2, 2. The cofactor matrix is 2, 6, -5, -2. And the cofactor transpose is 2, -2, -5 and 6. Good. And the inverse matrix is the division cofactor transpose divided by determinant of the A. In other words, this divided by 2. So it's 2 -5 over 2. No 2. Is 1, because 2 divided by 2 is 1, -5 over 2, -1 and 3. Okay, so say I want to find a solution for the system. Now you multiply the inverse matrix times the vector que we have at the right hand side, que es 7 and 2. Entonces es 7 minus 5, que esto. This is -7 plus 6 is -1. The solution is 2 and -1, que es the order pair 2, -1. Okay, 47 is very similar. The matrix of the system is the same, determinant is 2, inverse is the same. So basically you multiply the inverse matrix times the right hand side vector, que is 13 and 5. Let's do the multiplication. Multiplication is 13 times 1 is 13, minus 5 over 2, -5 over 2 times 13 is like 25. No. This times this, and this times this is -25 over 2. This is equivalent, this is 26 over 2. So LCD is 2, 26 minus 25 is 1. That's 1/2. The answer is 1/2. This times this. Ahora, this times this is -13 plus 15, que es 2. The answer is 1/2 and 2. Now the order pair solution is 1/2, 2.